Alright, in this video I want to talk about temperature scales. And what I mean whenever I say temperature scales is like, degrees Fahrenheit, from negative whatever all the way up into like, 200 degrees Fahrenheit or negative 30 degrees Fahrenheit to 220 degrees Fahrenheit. That's an example of a temperature scale, and it ranges in a broader range than that, but that's what we're talking about whenever we refer to temperature scales. So let's say we've got degrees Fahrenheit. We also have degrees Celsius. And we even have a thing, and I think I'm probably going to make a separate video on this, but I'll talk about Kelvin. And you'll notice Kelvin doesn't have a degree there. Kelvin refers to absolute zero, and it's really the measure of kinetic energy. So it's not so much in the greater scheme of things as judging between hot and cold, which is generally what we refer to with temperature. If something is, in America at least on the Fahrenheit scale, if something is, generally cooler than body temperature, or like, say around the 30s or 20s, it's generally considered fairly cold. Well, you could kind of say the same thing with Kelvin, but it's really judging the amount of molecules that are moving at that given temperature. But we'll save this for a whole other video. For right now, I want to talk mainly about degrees Fahrenheit and degrees Celsius. There is a difference, and if you're basically anywhere else in the world other than America, you're most likely going to use degrees Celsius. And I like degrees Celsius. I wish America would switch to it because it's fairly simple in the scheme of things as far as science and healthcare and things like that go. For instance, on the degrees Celsius scale, the freezing point for water is 0 degrees. You can turn around and go to the boiling point of water is 100 degrees. They're nice, whole, even numbers there, as opposed to the freezing scale on Fahrenheit is 32 degrees, and the boiling point is 212. So it's not even like there's a symmetrical, 100 degree increase or decrease or anything like that with Fahrenheit. It's just kind of, almost seemingly random numbers in there. So as far as degrees Celsius goes, it's much easier and I guess more user-friendly than Fahrenheit. So I personally would like to see a switch to Fahrenheit, but that's not the purpose of this video. The purpose of this video is going to be, one, how to go from Fahrenheit, degrees Fahrenheit, to degrees Celsius, and then to go from degrees Celsius to Fahrenheit. We're going to work on both ways just to get you a nice overall spectrum of the knowledge here. So let's start with Fahrenheit. Let's say let's start with Celsius. Let's start with degrees Celsius. Let's say we've got, let's say 20 degrees Celsius. I wrote that backwards. Let's say we've got 20 degrees Celsius, and we want to know how many degrees Fahrenheit 20 degrees Celsius is. Well, here's the formula for going from Fahrenheit to Celsius. You take 1.8 times your degrees Celsius and add 32. And this is really easy. If you're ever abroad and you want to know kind of what the temperature is, you can kind of get by with just taking 2 and multiplying it by your degrees Celsius and adding 32 to this. So for instance, this would be 40, add 32, and you're a little less than 72 degrees on that. You'd be like, 67, 68 maybe, somewhere in that range would get us pretty close. So I can kind of eyeball it and tell you that's about what it's going to be right now, but let's work it out. So to rewrite this problem with the 20 degrees in there, we're going to have 1.8 times 20 degrees Celsius plus 32. And really, I should write, just to make this algebraically correct, I should write it like this, plus 32. So let me grab my calculator here and pull it up. All right, and I'm just going to take, let me pull it up a little bit further so you can see the formula. All right, so I'm just going to take 1.8 times 20 plus 32. And that equals 68 degrees Celsius. So my guess was pretty accurate there. 68 degrees Fahrenheit. So that's basically how you do degrees Celsius to degrees Fahrenheit. If you're in Dunaway's class, she gives you this formula, I believe. If you're in High's class, he will give you this formula, but on the final he will expect you to know it. And I'm pretty sure Dunaway will give you this formula. But if not, this is one of those things where this is really something that's pretty valuable for you to take away from chemistry. If you're ever, I don't know, in the supermarket or watching global news or anything like that, you'll kind of sound witty and smart maybe to all your friends. So I don't know, just fairly simple formula. So hold on to it, keep it for life, may come in useful someday. Let's talk about going from degrees Celsius to Fahrenheit. We have our formula here. All we're going to do is use basic algebraic expressions to solve for Celsius with this. So we have plus 32 over here. So we have this equals Fahrenheit. And we want to get the Fahrenheit, the Celsius by itself instead of the Fahrenheit. So we have plus 32 over here. So we're going to do minus 32. Minus 32. These cancel out. All right, just go ahead and put parentheses around that. And then we have 1.8 times degrees Celsius. So we're going to divide both sides by the 1.8. By the 1.8. The 1.8 over here is going to cancel out, and we're going to be left with degrees Celsius equals Fahrenheit minus 32 degrees Fahrenheit minus 32 divided by 1.8. All right, so let's take, I don't know, let's say 60 degrees Celsius. We've got 60 degrees Celsius, and, we're wanting to solve for Fahrenheit. So let's say 60 degrees Fahrenheit. Here we go, 60 degrees Fahrenheit. And we want to figure out how many, or what the degrees in Celsius are going to be for 60 degrees Fahrenheit. So all we're going to do, and I'm running out of a little bit of room here. Let me just scroll down a little bit. We'll go right there. All right, so we've got 60 degrees Fahrenheit. That's the second time I've done that. I don't know why I keep doing that. 60 degrees Fahrenheit. And, it's been a long day, so sorry if I'm doing anything that seems goofy. 60 degrees Fahrenheit, we're going to subtract 32 degrees and then divide that by 1.8. Alright, so I know that's going to be 28, right? If I subtract 30 from 60 is 30, do another 2, and that's 28. And if I divide that by 2, let's just say I round that up to 2. If I divide 28 by 2, I'm going to be left with 14, right? So I know I'm going to be somewhere probably around, like around 14, maybe 15, possibly like, closer to 16, somewhere in that range. Between 14 and 16 degrees is going to be really accurate as far as where I'm going to be. So if you're ever out abroad, you can make this a 2, and you'll want to go up because you're dividing. I wanted to go down because I was multiplying over here. That's just tidbit knowledge. But anyway, let's go ahead and plug this into our calculator. All right, so I've got 60 minus 32. And you'll want to make sure you hit the equal sign here with most calculators, unless you enter the parentheses in with your scientific notation. And the reason being is because you'll get a different answer unless you do. You want to make sure and subtract the 32 from the 60 first, and then divide that number by 1.8. So we've got 28 here divided by 1.8. So 15.5. So I was fairly close with that there, between 14 and 16 degrees. And that's also a way you can kind of do a mental check at the end of these problems and see if you're on the right track. Did you do it right or did you do it wrong? So this is really a skill that you're going to use a lot in chemistry on that. So that's going to equal 15.5. And what you're going to find out is when you get later on with problems, you may be given a formula of, let's say, I don't know, energy equals specific heat times mass times delta T, the change in temperature, and they want you to solve for the delta T in, I don't know, Fahrenheit, but they give you the specific heat. The units of measurement for the specific heat are joules per grams degrees Celsius. So maybe they're giving you Celsius, but they want your final answer for the change in temperature here to be in Fahrenheit. That'd be an example of how you could see this thrown into a problem. So you'll use this periodically here and there all throughout your semester in chemistry. Anyway, I hope that was helpful. Stay tuned to the next video for Kelvin.